Hello friends, today I am going to discuss one most important model it is a third supervised machine learning model, and this model is called a KNN model. So just I have already discussed in the previous video two and more models, two models I think. So if you didn't see my previous video, so try to see it will be better to help to understand this model. And so KNN model tries to find a nearest neighbors to a data point and uses their value as a predictions. So as a mathematics way you can define the nearest neighbors like a definitions like a nearest neighbor. It is based on the computations of the Euclidean distance. Just if you are aware with the coordinates, it's a x-axis and a y-axis, both are the intercepting and the origins. And if you are getting a distance formula from point A to the B, it depends on the where is a lies called quant 1, quant 2, quant 2, 3 and quant 4, it doesn't matter. So the Euclidean distance formula we can write here the AB will equal to a square root x2 minus x1 whole square plus y2 minus y1 whole square. Similarly we can go further. So this is the Euclidean distance, and if you write here the P and Q, so that you can write the P1 minus Q1 whole square, P2 minus Q2 whole square, and till Pn minus Qn whole square. You can write P and Q are the data points, each with the n dimensions. So generally mean that there are the n explanatory variables in the data sets. So you sum the square distance for each dimensions and finally take a square root. Letter K is used indicate the number of neighbors to use to compute the K nearest neighbors. So if we are going to get a distance between your new data points, and each of the data points in the training data, depending on which number you have for a K, that take the K data point that have a lowest distance. So many distance, so you can take a lowest distance and then we can combine. So combining the K neighbors into the one forest, and we can identify a K neighbors that are closest, and you can say here like a simply to take the average of the target variable values of the K nearest neighbors. This average is then used as the predictions, and the second method is to take a weightage average of the K nearest neighbors and used their distance as the inverse weight. Now deciding on the number of neighbors K, and so end of these things remain to be decided on, and that how many nearest neighbors you want to include in the predictions. This is decided by the value of K, and applying this to the previous just we have already discussed. So one nearest neighbors and the three nearest neighbors, so two different cases 1 2 3, and so the different type of the nearest value. So if you write the 1 NN predict the simply, and 3NN like a 3 nearest. So let's see, just I am going to take here like we are predicting a traffic using KNN models. So I am collecting a data like a metro interest traffic's volumes, and you can collect this data like a archive uci.edu.com. So you can archive.ics.uci.edu. So I am also collecting a data from, it's a zip file, so you can compress like the gzip. So first I have imported and I have done this process, and we now I am going to see my data as head, and this is the head of this data. So it's a data, so I am not going to get a like a error in the like a previous video. I am directly improving my model. So let's just I am collecting a data, so we can see the so many variables in my data like a, you could see here in the holiday, temperature, rain underscore 1h, snow underscore which, weathers descriptions, date underscore time, traffic volumes, year, months. Okay, so many numbers of data means columns like a month, weekly, hours, is holiday. So these are the, so the year, month, weekly, hour is a holiday, month, weekly, hour is holiday. These are the our features engineering to create the additions explanatory variable, and I will create like a year, month, weekly, hour and is holiday as a feature, like a, as a explanatory variables. So let's see, just I am creating the explanatory variables. These are the explanatory variables like the data and year, data month, data weekdays, data hours, data is holiday. So just I am as going to split the data into the train and test fit a default like a KN model. So this will get you first fill of R square that could be obtained with this type of model. So go ahead. Now I am already, my data has been converted like this as a lambda way. So you can see like a, these are the feature engineering. So I have done like a year and data, date underscore time. Now apply here lambda functions here and slice 4, and here we are talking the only 4th row. We will start from the month like a 5th to 7th row, and data week days, just apply the x, and weekdays all, hours we can apply all here, and data is holiday like a none dot apply here like a flow. So we have already like split the data into the training and test with default like a KNN model. Now I am creating a data train and test split and computing the R square of the default model. So let's see the x as a data, year, month, week, days, hour is holiday, and y as a this. Now I am going to the training and test. So from sklearn dot model underscore selection import train underscore test underscore split and xtrain, xtest, ytrain, ytest and train test model. We are taking a like a explanatory variable and any deep independent and dependent variable. Independent variable like a x and dependent variable like a y, and I am writing the test site like the 100 because I will not able to take the more, so we don't have the more time. So the random states like we won't like to change my variables again and again. So and shuffling like a false. So from a sklearn dot neighbors import k neighbor regressor. So just I am creating a alias like a my underscore dt and k neighbor regressors and my underscore dt is alias. So let's see, just I am going to start my underscore dt dot fit and 10 x10 and y10. Forecasting my underscore dt dot predict and x underscore test, and from sklearn again we are going to the user matrices import r square. Just I have discussed like a different type of the matrices, mappy, p, p r square and other so many. So these are the matrices. So here we are I am using here the r square matrices. After that, just I have gotten the r square like a 97%. It's a really good and surprise here. So it's a positive surprise. So the r square is on this model is a very good at already. So 96, at least 97% we can say here. So this should mean the forecast is not far from perfect. So let's to try verify this visually. So I will try to, so let's the positive surprise. So I will see here like the import the matplotlib and dot pyplot plt dot figure, and fixed size you can depend on your requirement, and plot like a x test and y forecast. A other is the forecasting actual and forecast traffic volume and steps and test in a test data. So this means then we will see here like your data is looking good. So and then after that I will try to apply like a from sklearn like a grid search on KNN, and I am using a grid search. So grid search k neighbors regressors, and you can applying the two parameters like a n neighbors like a 2 4 6 8 10 12, and is scoring r square in jobs like a -1, and my underscore knn dot fit x10 and y10 print r square underscore list y test list my knn product x underscore test, and print my knn dot best underscore estimator like the 97%. So it's a good. So k neighbors regresses, and we can see here like similarly. So now r square obtained with the turn the model 96 95 it becomes the 97. So this model use the 8 nearest neighbor rather than 5. So then it's a beta to 0.0 and r square scores, and this is the very little, and therefore the improvement can hardly the considers existence. In this case the default model was actually quite good from this is way. So I hope just you can understand this model, and after that I am using the writer sklearn dot model underscore selections import a random jet search cv, and random jet search cv it will see the same result like this. So it's a very good model, and we can easily predict here like a k neighbors network here like this one, and it's a will be really very very good. So let's see here the just I am using here like other alternative like a grid search. So random search has been allowed to the to choose any number of the k between like 1 and 20. The argument in iterations decide on the numbers of values should be randomly selected within this range. So what do we learn from the KNN model based is predictions on the value of its nearest neighbors. Another, the neighbors value are combined into a predictions by computing the average or weighted average based on their distance. The Euclidean distance generally used for a distance measures, and the number of neighbors to use a combinations is denoted a k and hyperparameters of the model. And next, the value of k can be optimized using the hyperparameters. Just there are two hyperparameters we have already used. Turning for just we have already discussed in the my examples through the grid search, cross validations, and random search is an alternative grid search that is the faster and generally give a result that are as good. So it's a very basic and it's a good model. So I hope you understand this model, and thank you very much for today, and let's see the next video. Thank you.